you just go over 3 briefly? I feel like I understand
Question
it.
3.
It's the one with the billiard balls with work. What does it mean with work?
It means there's an this looks like it's a elastic collision, but work would indicate a loss in kinetic energy, I think. Okay. So which part of the third question, or all the parts?
Let's see. I think maybe all of them.
Okay.
Maybe I got the first part. It's possible.
Okay.
I underlined the third part. Okay, I mean, I know that like, so you have only an x direction, and then you have an x and y direction.
Yeah.
So you have to do with trigonometry.
Yes.
Which is, the only kind of weird thing is, I think I watched one of the videos for this one, and he like made a system of equations with x and y, and then did some strange things. I'm not exactly sure what.
Did he use matrices or something?
No. But if he did, I would have been more confused.
Yeah.
Just throwing that out there.
That would make sense.
Yeah. I don't know so much.
They make really problems with lots of equations a lot easier to solve.
Easier?
Yes. So much easier. You just draw 2 matrices, plug it into your calculator, and push enter, and it solves the whole problem for you. It's kind of wonderful. But it asks how to find the final speed. So you have what? Like this. This is what angle W and B, and this is B not 21. Up B 1 2. That makes sense, right?
Wait, oh yeah.
Okay.
I got the picture part.
Yeah.
That part, yes.
So just making the momentums, making the vectors.
Sure.
The momentum, and then solving based off of like sum in the x has to be 0, and
There's some what?
well, if x was initially 0, or no, not x, sorry, y.
Y? Okay.
Y was
Okay,
initially
yeah.
0, so the y components of both of these have to be equal.
Yeah.
Then you could, so that's how you end up with a system of equations. You have one saying that V2M2 sine angle B is equal to M1 sine angle W, and then you get V1 is equal to V1 F1 cosine. Did those equations make sense?
I think so, yeah.
Yeah.
Yeah, and then you will have to set, like, because he had an equation for the x, and an equation for the y direction, and then you kind of make 4 equations into 2, then 2 into 1.
4 equations?
Yeah. I don't know.
Huh.
So, like, mvw cosine theta w equals 1.62, which is the mass, times vw cosine of 58.
What? Okay.
So it's,
That sounds extra complicated.
yeah, it's maybe, it may be.
Maybe.
Maybe why you didn't. So, and then that was just one of the sets. There's another set of them. This is, maybe I just misunderstood.
Oh, okay.
So this is like a velocity white, so like white and then black.
Yeah, he just took this is the x component and then he plugged in numbers. So it's not really so much an equation as it.
But then it's like this will be equal to, oh,
Right?
yeah. Wait, so it'll be this equal to this and this equal to this, which equals 0.
No, this is equal to this.
Yeah.
This plus
This
this
equals
is equal
0.
to, no,
Yeah.
2. This plus this is equal to 0.
But it's x.
Sorry, you're right.
Okay.
Y, this plus this is equal to 0, because I did y on top of it.
Okay,
And
okay.
this plus this is equal to the original.
Okay.
1, whatever that is.
Okay.
Does that make sense?
Yeah.
Okay. Could you figure it out starting from the beginning?
Maybe.
Maybe.
There's a chance. There's a chance it's more than 0. But
Okay.
not like 90, you know. Just somewhere.
Somewhere. Okay.
I understand what it's asking. I understand how you do it, you know. Just actually doing it from scratch. And we'll see, I guess.
Okay.
I don't know. Okay. Is collisions, impulse, and reference frames easy? The next thing?
The next thing?
Is the,
That sounds like more of what you've already been doing.
yeah. Impulse examples. What is I remember.
Impulse is, it's J, right?
J.
Maybe, I think. Or it's something like that. It's some letter. Oh my goodness, these videos are so evil.
Evil?
I hate them.
Why? Why are they
They're boring
evil?
and unhelpful. Yeah. Is impulse it's like changing something over time. I know that is super.
Now, one just general question that I have. I feel
Yeah.
like a lot of the equations that this video gives you is like it has a lot with integrals,
Mhm.
and then we never actually did any class.
Mhm.
Is that
Yeah.
because nobody knows integrals, or is that because it's not relevant?
That's because
Like, I don't know.
it's more because nobody knows integrals and
Okay.
it's not relevant.
Okay. So, because like work equals integral of f times d or whatever, but
Mhm.
we never actually did anything with integral. Or did we?
Technically,
And I just didn't notice.
like for these kinds of problems, really you can solve that for everything. So work equals integral of force dot d or whatever, right? So work of friction is equal to the integral of force of friction times like this is like dx or something, right? Dx. And if so that's equal to cosine of the angle, force dx, which typically it's moving in a straight line. So it's just that really just
Just
if force is constant.
Yeah.
Right? We're always using force as constant. So it always just becomes cosine force times distance times the angle between for friction. And then say like spring work, you have spring force is it's Ks dx. K is constant, so the integral of that is 1/2 Ks.
Oh my
Yeah.
never
That's a better example than the friction
Wow.
one. Yeah.
Okay.
And actually for kinetic, I believe this comes from momentum, right? mv over squared. Because mv, change in momentum can also be used to calculate force.
Okay.
So, yeah, that's why force is equal to dPdt is equal to ma. It's related to momentum. Yeah.
That makes sense where they come from now. I kept seeing him write
So
integrals and I
the
never do
integrals
anything
are
with them.
there, but they just did the integral for you and you have an equation now. Most things in physics or really any engineering class, there's just you can know that it's technically the integral, but it's always going to be done for you. There's another equation. Even diffie-q, technically that's being used in pretty much all of my classes, but I've never solved a differential equation in them really technically.
Oh. I'm gonna ask you calculus 2 question. What are you saying? Midterm. Oh, it's so bad. Oh my gosh. I always go to office hours because me and Fang are friends, as I've told you. And he tried to get me off topic the other day, so I could stop asking him questions. But it didn't work. He's like, oh, this problem's gonna be easy. And I'm like, okay, fine, all right, dude. And then he sits there and for over 5 minutes, he keeps going up to the board, tries something, doesn't work, sits back down. Goes up to the board, tries something, and he was like, well, oh, I think maybe one more way, and then that way worked. And I was like, oh.
Oh my goodness.
He's like, I bet if I put this on the test, only 2 people get it right. And I'm like, it's not me, right? He's like, yeah. So that's pretty good.
Wow.
No. But that makes, so now the question is, has he made the test and not put it on? He said, if I were to put it on the test. Or has he not yet written the test? I told him, I bet the 98% of people who get it wrong would appreciate if you didn't put it on there.
Yeah.
And he just kind of looked at me like, yeah, right. So I don't know. It's hard to find out, but.
That's funny.
He made a review sheet for a test maybe 3 years ago when he taught the class before.
Okay.
And then he's like, oh, and he told me like, so I was just going to use the same review sheet. But the problem is I lost my answer key. And in class he's like, so do you guys want an answer key? And everybody's like, yeah, we do. He's like, oh, no, I got to stay up all night writing you guys one. And he sent it to us at like 12 a.m. with a very passive-aggressive message attached, like, hope you enjoy your answer key. So.
Is he a younger teacher or a older
I mean, he
teacher?
has a daughter in kindergarten, or no, daycare, still in daycare. So
Okay.
I think he's like 35. Guess it's a good guess, maybe.
That's probably
maybe.
a good guess.
I don't know. He's a pretty nice guy. Yeah.
Okay.
He's good at math.
Yeah.
I was just asked like what reading material he has, and it was like Newtonian methods of unstable materials, and
how
like what? I don't know.
how understandable.
Yes, relatable. Very.
You can start a conversation off of that easily.
Oh yeah, I can be like, so what does that do? And then he'll say a lot of words, and I'm gonna be like, that's cool. Same here, actually. That's what I do. Okay, so let me ask a question about the lab before I have no more time. I just have to pull up the lab. Okay.
I can pull up the two. This one here.
Yeah, but tomorrow's gonna be the greatest day ever because I have physics recitation, then physics lab, then a CS exam, then lunch, then the calc exam.
All of that before
then
lunch?
psychology. No, lunch is in the middle. But
Oh, okay.
It's still. I don't know what I was thinking putting all my
that's a
classes
long
on
day.
Wednesday.
Yeah, that's not the best plan. No, after assignment due tonight, assignment due tomorrow morning, and
Oh.
then I'm gonna take a really long nap.
That's a
That's
good
my
idea.
entire Wednesday. Really,
I might
long
do
nap.
that as well. I just, my grades might not do so well.
Yeah. You could do that on Thursday. Wait, do you have more midterms on Thursday too? That's
Thursday
ridiculous.
night from 6 to 9, I got a history midterm
That's
that I have not begun studying for at this point. But it's okay because I got a quote very good on my first paper. So I don't know what grade that translates to.
Yeah.
But I mean, hey,
That's
I will
nice.
take it.
Yeah.
I saw a lot of people had C's on their papers, so I was like, all right.
Very good.
The only
Works
comment
for
put
me.
on mine was that I was missing page numbers.
Oh, okay. That's pretty good.
That's pretty good then, I hope.
Yeah.
But,
It would be an annoying thing to get points off for.
yeah. I mean, it is kind of my own
Yeah,
fault because
but-
I didn't read the instructions.
That's
But,
okay. Whatever. Which
okay,
lab
we're
is
on
it?
lab 5.
At Wood Machines.
Yeah.
Okay.
So good. Okay, so
Mhm.
the questions at the end.
Mhm.
I should probably have them. Okay, so for
At the end.
okay, I just this isn't like a concept question. This is like an Excel question.
Okay.
Like I know I use computers pretty well, right? But I don't know. So it says don't forget to include error bars. Does it really mean like just do this?
Yes.
That's it?
Literally.
Okay. Also,
You don't have to make them accurate error bars.
you just have to put them
They
on.
just have to be on there. You don't have
Okay.
to explain them or know what they mean.
Yeah, I was gonna be like, I don't know what.
Yeah.
But they don't look like there are a lot of them, so
Yeah,
I guess that's good.
It has to do with statistics, and so you're supposed to, when you use error bars, set them like to be certain ranges, but Excel just chooses the same range for every single problem and gives you error bars like that.
Because we didn't actually understand what that meant, so we recorded error percentage for every trial, and didn't know if I can do something with that or if I can just delete that whole thing.
There might be a way to use that
Okay.
to adjust the error bars, but I don't think it matters.
Okay. All right. And it says that we're supposed to graph F versus A, so net force versus acceleration. Experimental, theoretical, both.
Was the force? How did you measure the force?
So net force is A3 minus B3 times 9.8.
So you calculated the force?
Here and here. Wait, 8. Oh, it's both masses. One mass minus the other mass times gravity.
Times gravity.
Yeah.
And then
The heavier mass is the hanging mass. So.
And then how did you calculate acceleration?
So
Which either acceleration, theoretical.
Oh wait, hold on. I think I might have.
I think you.
No, because there is no theoretical acceleration for the first part. I don't think they asked you to find that.
If you usually you wouldn't use theoretical acceleration versus anything except for. You might do theoretical versus actual to see if it's a straight line.
Sorry, I actually did that. Do both.
Okay.
So the theoretical is A4 minus B4 times. Oh, it's the change in mass times the gravity over the total mass.
So it's the force.
It's the force over the total mass.
Yeah, so don't graph that
Don't graph
against
that?
force, or
Okay.
else you'll get a perfect graph.
Yeah.
Yeah.
Yeah. Okay. Let's get it. Oh no. No. Okay. So just this one. I mean, it's pretty close. It's 0.999.
Yeah.
Okay. Then. Don't forget. Okay. So then there's something. So what is do you think there's a better way to write m1 minus m2 over m1 plus m2, or just
do that.
Just okay.
It's easier.
Okay. Then explain what the slope of this graph represents. I think it's supposed to be gravity because when you do the theoretical one, it's 9.8. Mine was not really 9.8, but I guess it's supposed,
yeah.
So it is supposed to be gravity.
How did you calculate the theoretical acceleration? Was it
Same as the last one.
Gravity?
It's this times gravity divided by 2. So then it's going to be gravity.
Yeah.
Okay, calculate tension for the second experiment. So how I did that is, so the heavier mass times 9.8 minus the lighter mass times the experimental acceleration.
Maybe.
Any chance? Any chance?
Let me draw it and
Okay.
think. This is a calculation for tension.
Yeah, for tension.
So you have.
So we have.
Okay. Larger mass, smaller mass. It's going to
Wow.
accelerate that way. There's gravity. And this is tension. I think we would have MA is equal to tension minus mg of m2. So tension equals m2 g, or
So they gave us equations for this too, by the way.
yeah.
Yeah.
Okay. This is a minus MA. It should be the same. What am I even doing? This acceleration is equal to that acceleration. The tensions should be equal. Usually you wouldn't know tension or acceleration, right? So you
just cancel tension out.
Yeah.
And then you solve for acceleration, which is how you get the m1 minus m2 times g over
So
m1
in this
plus
one,
m2.
instead of canceling tension out, cancel acceleration out, right? So acceleration is equal to 2 minus m1g over m1 is equal to, here acceleration is we can solve that for tension. Yeah. Whatever you said sounds like it might be right.
Okay.
What am I doing? What did they give you equations as?
If you scroll up to page 1, it gives you the things that you came up with. Basically.
Yeah.
Yeah. Right there.
Okay. Yeah.
And then there are 2 more on the next page, but I don't think the 2 more on the next page are. Let me see. I don't know if they're useful.
Yeah.
No, they're not. They don't.
Equals 2 m1 m2g. Is that what you got?
Let's check.
Maybe.
So minus. Oh no, not really. Not so much.
Okay.
I mean I'm not right.
You might be right, I might be wrong.
So I have like m1 times 9.8 minus m2 times a, being the experimental acceleration.
What is A again?
A is the experimental acceleration that we found.
Yeah.
So it's the acceleration of the system.
Oh, the experimental.
Yeah.
Whereas that didn't end up in this equation at all, because I canceled out A in order to get only one variable.
But we have like a column of A.
Yeah. And this is supposed to be theoretical tension or experimental tension?
So I did, but I mean the theoretical and experimental only differ by changing which A you plug in, right?
Oh, okay.
So
if you're gonna do it by plugging in A, then only use like this equation or this equation, right?
Yeah. Which is why I think I was on the left side, second equation down. I think that's where that came from. Yeah, because I have m2. Wait, because I have m2g minus m2a.
Okay, that's right.
But I have m1 instead of m2.
Yeah.
But I don't know.
You wouldn't have a mixture of m1 and m2 unless you were trying to find that.
Okay.
Which
Am I maybe supposed to find that?
I don't think it really matters. But if you plug in the theoretical acceleration, you should find that.
Okay.
It should be the same.
Okay.
Yeah.
Got it. What is the relationship between the acceleration and the total mass when the force is held constant? How do you hold force constant? What do you mean?
What did you vary in the experiment?
So I don't know which experiment this is asking about, but for the first one, you kept the system the same, and then you like added more to one side and subtracted more from one side.
Okay.
But it would always fall the same way.
Okay.
In the second one, this side stayed the same, and this side just kept getting heavier and heavier.
That's the one it's asking.
Okay, that's the one it's asking about.
Because you're changing the applied force on the left side.
Changing the applied force on the left side. Okay, but it says, what is the relationship between the acceleration and total mass when the force is held constant? When the force is held constant. What's the relationship?
That's MA is constant.
When MA is constant, the force...
When the force is held constant...
What's the relationship between them? They have to be in... That could be completely wrong.
Is that the force on one side is constant?
Yeah.
Because it's the weight. That side is constant. The other side, you're changing the mass.
Yeah.
And so when force is constant, that doesn't make sense. You think from the equation, F equals ma. If the force was the same, then as mass goes up, acceleration goes down.
Inverse.
Yes.
Yes.
That's not inverse.
I mean, it's an inverse relationship.
Yeah.
But they're not like inverses of each other.
Yeah, but that doesn't make sense.
Okay.
Oh, well, the force isn't constant anymore.
Yeah, which is I don't really understand how we're supposed to like figure it out.
I think I can remember not understanding this question when I did this lab. This is lab number 5.
Lab number 5, yeah. Also, do you know how I get less sig figs? Because I lost a point on my last lab because I had too many sig figs.
You say, what was it? I can't remember the command now. It's like, might be a rounding command.
Okay.
Or something like that. machine. When force is held constant, acceleration and total mass would have an inverse relationship. Okay, I didn't. That's all I said. I explained that equation. I didn't use any data to support it. That's
So you just said there's an inverse relationship?
Yep.
That's it? All right.
And I didn't get marked off for that. I got marked off for something else. Oh, yeah. And I did the, that's the one I did the wrong graph in. I did force versus, I used experimental acceleration to calculate the force and then graphed that versus the experimental acceleration. Got a perfect graph.
That's pretty good.
No, that's
No.
bad.
That's. And then how do these measurements, whatever these measurements are, compare with calculations using equation 3? How do these measurements, equation 3?
Equation 3 was A equals M1 minus M2G over M1 plus M2. Is that equation 3?
Probably.
I wrote it as equation 3.
M1 minus M2G over, yeah.
So the question is, how do they?
How do quote, these measurements
Relate?
compare with calculations using equation 3? These measurements being
Experimental versus actual.
accelerations.
Yeah.
So should I make like a a graph of them?
Yeah. Say the slope isn't 1-to-1 because they're not quite exactly the same, but they're almost.
Charts. The slope is. Let's see. .0455.
Yeah, that's good.
That's pretty close.
Say they're depending on which one's on each axis.
Yeah.
It's slightly faster or something.
Okay.
Or in friction.
Okay.
Or the pulley wasn't actually ideal.
Oh yeah, because part of the question is, how well does the ideal pulley scenario hold? Not well.
Not that one.
Not well. Explained because of friction.
Great. Well, you assume that
The
the
pulley's
pulley
not
is
massless.
massless and frictionless, so
Okay.
you're not taking twists into account.
Yeah. And that's like for sources of error again. Probably friction.
And the pulley.
And the pulley. Okay. Let's see these things. How do you do trigonometric integral substitution?
Trigonometric integral.
With the square root of a squared minus x squared and the tangent squared minus 1 equals secant squared.
Whatever,
How do you do those?
What?
What do you what? Hold on.
Changing it from a. Is this polar coordinates?
What? No.
What
No.
are you
Hold on.
talking about?
Hold on.
I haven't done this in a long time.
All right.
To be real honest.
All right. Hold on. So we got like
Oh, fun.
these and
Oh,
yeah.
I know this.
You know this?
I think.
I just can never figure out.
have
I can
my
just.
cheat sheet that tells me how to do it.
What? Oh, let me grab one of those. What is
Did I
that?
write that on here?
What is this?
I don't think I did.
You got these.
Yeah,
You
here's
got
the
to.
substitution.
Yeah, but how do you know when to use them?
when it looks like that.
Oh, great. You sound like banging on the bottom and on the next page or whatever.
I don't remember.
All right, nice.
To be honest.
Yeah, it's.
Yeah, that was really fun.
This is the one that took him forever because you have to like factor it or no, you have to do. I don't even know how you take roots of things. Like you change it into something squared plus something. I don't even know how to do that. Like we never did this.
Oh, when you.
I don't even know how to like.
Okay, so if you have
Factorize.
like.
That's what the word is.
Like x.
Like x squared plus
3x. Or something
no,
like
but it
that.
has to be not perfect numbers. No, it has to be like
Choose
x
some
squared
number.
minus 47 plus 12.
X plus
Yeah.
12.
And then you
So-
change it into x squared plus
Yeah,
something
you
plus
find,
something.
for squared, it's the middle number
It's
is
like
going to
b
be
over 2.
2b. Wait, no, it's
Isn't it?
b times. Right, this is b squared, and that's just 2b. So that's just. So you get x squared. Does it end up being minus in the middle? Yeah. Plus 47
What do you-
over 2 squared.
That's not what I meant.
Right?
That's not what I meant. No.
No.
No. It has to be.
Yeah.
It has to be some. No. It's like. Okay, hold on. You lost me.
What?
You lost me.
Okay.
Okay. So it's like x squared minus 47 over 2.
Yeah, and then it's like
squared
plus 12
12 over what?
minus 40.
What? Why?
over 2.
Why? No. Why is this plus 2 here?
This is. Okay.
Okay.
So for this, we choose easier numbers, please.
Okay.
I'm going to do 4 plus.
But
4 is easy to do. This is going to be 4x plus
Yeah.
7 because you can't factor that, right?
okay.
It's just as horrible numbers, but easier to
Okay.
do. So for this, you would say half of 4 is 2. 2 squared is 4. So plus 4 minus 4. And then I'm going to write this. So x squared minus 4x plus 4
X
plus
minus
7 minus 4, right? So you've added 4 there, subtracted 4 here.
plus 4 minus 4.
Yeah. So
Okay.
then
All
this
right.
becomes x squared plus 2.
Squared.
X plus 2 squared.
Yeah.
Yeah. Plus 3. Right.
Okay.
So you do this number divided by
2.
2 squared, and you add and subtract.
It's just that number. What do you mean? Wait, no. You said, okay, hold on. You said it's this number divided by 2 squared, but it's just this number.
I chose 4. That was a bad number to choose.
Okay.
So I'm going to do variables.
Okay.
X squared plus bx plus c.
Yeah.
Because that's normal. And then you change that to x squared plus bx plus 2b, wait, no. B over 2 squared plus b minus b over 2 squared. Because you have to add it and subtract it, right? So that it's still equal to the same thing.
Okay.
It's like adding 0.
Okay.
So this becomes x plus b. This should be minus.
But it doesn't have to be.
Does it
minus,
have to
right?
be?
I don't think it has to be.
No, it doesn't. If it's minus, then this is minus or something like that.
Okay.
Squared plus c minus b over 2 squared.
Wait. Okay.
Does that make sense?
I think so.
Because if you multiply this out, you're going to get x then you're gonna.
The only thing I'm a little confused is I thought
should be p over 2.
I thought that he said that this wasn't squared. But it is.
That wouldn't make any sense.
Okay, so it is squared.
Mm-hmm.
Okay.
Have the same number.
So it's x plus b over 2 squared plus c minus b over 2 squared.
Mm-hmm.
Okay. And what is this called?
I don't know.
Okay. I don't actually know what this is. I just know that it's a thing that you have to do sometimes.
Yeah.
Okay.
Mm-hmm.
Got it.
Hopefully that's helpful.
Do you want me to sign in?
I almost. Oh yeah.
Okay.
That would be great. Yeah. Well, now we've recorded a nice explanation of calculus as well.